Types of statistical studies. In an observational study, researchers observe or measure characteristics of the sample members but do not attempt to influence or modify these characteristics. For example, we ask a sample of people whether they filed their federal taxes last year. Only recorded data is reported. In an experiment, researchers apply a treatment to some or all of the sample members and then observe the effects of the treatment. For example, in a drug trial, groups receiving medication are compared to groups not receiving medication to evaluate difference between exposure to the drug and non-exposure. Treatment and control groups. The treatment group in an experiment is the group of sample members who receive the treatment being tested. The control group in an experiment is the group of sample members who do not receive the treatment being tested. It is important for the treatment and control groups to be selected randomly and to be alike in all respects except for the treatment itself. Placebos and the placebo effect. A placebo lacks the active ingredients of the treatment being tested in a study, but looks or feels enough like the treatment so that the participants cannot distinguish whether they are receiving the placebo or the real treatment. The placebo effect refers to the situation in which patients improve simply because they believe they are receiving a useful treatment. Blinding. In statistical terminology, the practice of keeping people in the dark about who is in the treatment group and who is in the control group is called blinding. An experiment is single-blind if the participants do not know whether they are members of the treatment group or members of the control group, but the experimenters do know. An experiment is double-blind if neither the participants nor the experimenters, people administering the treatment, know who belongs to the treatment group and who belongs to the control group. Example: one of what could be wrong with this sample. A chiropractor performs adjustments on 25 patients with back pain. Afterward, 18 of the patients say they feel better. He concludes that the adjustments are an effective treatment. Analysis. Everyone in this study is a treatment group. Without a control group, we do not have comparisons to individuals who were not adjusted. The 25 patients who receive adjustments represent a treatment group, but this study lacks a control group. The patients may feel better because of a placebo effect rather than any real effect of the adjustments. The chiropractor might have improved the study by hiring an actor to do fake adjustments, one that feels like a real manipulation but does not actually conform to any chiropractic guidelines on a control group. Then the chiropractor could have compared the results in the two groups to see whether a placebo effect was involved. Example 2 of what could be wrong with this sample. A new drug for a type of attention deficit disorder is supposed to make the effect of children less disruptive. Randomly selected children suffering from the disorder are divided into treatment and control groups. These in the control group receive a placebo that looks just like the real drug. The experiment is single-blind. Experimenters interview the children one-on-one to decide whether they became more polite. Analysis. Best practice is to double-blind a study to avoid bias from the diagnostics group. The experimenters know which children received the real drug during the interviews. They may inadvertently speak differently or interpret behavior differently with these children. The experiment should have been double-blind so that the experimenters conducting the interviews would not have known which children received the real drug and which children received the placebo. Retrospective study. A retrospective study, or case control study is an observational study that uses data from the past, such as official records or past interviews, and in which the sample naturally divides into a group of cases who engaged in the behavior under study and a group of controls who did not. Which type of study should be used? For each of the following questions, determine which type of statistical study is most likely to lead to a reliable answer. 1. What is the average income of stockbrokers? Observational study. No research or intervention is needed to obtain this data. 2. Do seatbelts save lives? A retrospective study. People who wore seatbelts in crashes represent the cases, and people who did not wear them are the controls. By comparing the death rates and accidents between cases and controls, we can learn whether seatbelts save lives. They do. 3. Can lifting weights improve runners' time in a 10-kilometer race? An experimental study. Comparisons can be made with an experiment, those lifting and those not lifting. 4. Can a new herbal remedy reduce the severity of colds? Double-blind experiment. A study in which some participants get the actual remedy while others get a placebo. We need double-blind conditions because the severity of a cold may be affected by mood or other factors that experimenters might inadvertently influence. Margin of error. The margin of error is used to describe a confidence interval that is likely to contain the true population parameter. The interval is sample statistic minus margin of error, comma, sample statistic plus margin of error. Let's work this in an example. Close election. An election eve poll finds that 52% of surveyed voters plan to vote for Smith, and she needs a majority, more than 50% to win without a runoff. The margin of error in the poll is 3 percentage points. Will she win? Before we begin this problem, let's understand that we cannot predict with absolute certainty whether or not she will win. However, the confidence interval will give us the likelihood. So let's write that. The confidence interval is 52% minus 3%, which is the margin of error, comma, 52% plus 3%. And so we get the confidence interval that is between 49% and 55%. We can interpret this as there is a chance she could win or lose based on the polling data.